Got it. Okay, good afternoon, everybody. I know you want to learn how to use Landsat data for your research, right? Or for teaching. And we already explained it, the spectral signature, right? Everybody now knows that every object in the planet has a unique spectral signature. Water, vegetation, soils, clouds, snow, you name it, it has its own. So I want to work with satellite data. What should I do? Well, NASA, or in this case, the US Geological Survey, created this website called Earth Explorer, okay, where we can download data from any corner in the planet. How do I download data? Again, you don't have to download it. I'm explaining how to. You already have the downloaded image, right? All right. So first, I need to go where I want to be. And I know you love Egypt, so let's go to Egypt now. I'm zooming out. Okay. I'm going to go to New Delta. It's my favorite place now. Okay. So, okay, I'm in the New Delta. How do I get data for this location? Well, you just use your mouse and make click. Once you do a click, this blue dot will show. Okay. What does it mean, the blue dot showing? Okay, how many of you answer? 1, 2, and 3, 4? Okay. Okay, gifts for you. All right, time to give you gifts. Okay, let's give you gifts. Okay, gifts.
I selected those.
All right. Gifts. Gifts for you.
See.
You answered.
And I answered.
Did you answer? All right.
In the balance.
Hey,
You
if
have
you
woman.
answer, you don't get a gift.
Okay.
And if you don't answer at all, you don't get certificates.
Good.
So that's the
Yes.
gender
balance.
have to answer the question. If you don't answer the question.
I answered it. See?
Okay, all right. All right. Okay, so now look, I have a marker now. Okay, I'm going to keep asking questions. Be listening. Okay, look, now I have a latitude and a longitude here. That's the location where now the website is going to look for data. Now, on the bottom, I can ask for a specific date. So I want to look data for this year, last year, 10 years ago. This is where I put. Also, I can look for months. Let's say I'm interested in only the summer month of July. So I can force the website to give me only data for July, or only December, or only March. Okay? So let's keep it for now like this. We will click on data sets. Now, this website, the Earth Explorer, will offer us a lot of data, including drones. Here, there is a tiny link that is giving you drone data. Here, it says UAS, Unmanned Aerial System. So there is an example of drone data there.
So now I select
from there you got
cover. I have to decrease like this.
Yes,
Yeah, no.
the UAS,
one step before.
Yeah, exactly. Then
the one step was,
From the date.
yeah, from here, I just put data sets.
Okay. That is it. Yeah.
Data sets. Okay, clear where is the drone data here? There is some drone data there. Okay.
UAS.
Okay, now, but I'm not interested in the drones. Drones are for tomorrow. Today, I'm thinking about Landsat, right? Okay, so click on Landsat. And I have 4 So 4, 6, 7 options. Which one do I need to choose for a prize?
Level 2, level
And the people that already got a prize don't answer.
Can you show, please?
No, I'm
No. Can you show him to know if I answered or not?
I'm waiting for a voice.
I think
No, and also who won already doesn't receive a double prize, just once. Okay. Which of these options? Okay, let me finish the question. Which of these options we want
level 2.
and why? I want an explanation. Why 2? Okay. Okay. You and you. What? Why?
Level 2 surface data.
That's incorrect.
Level 2 surface data.
Why?
Certain more accurate and
What about level 1, level 0?
Level 1 is
All right. Okay. Why? Good. All right, yes. Level 0 is raw data, digital numbers. We only if you decide to spend your life studying Landsat, that's the data you will select. But no, you need the data to make decisions, not to evaluate the pixels. So level 1 is top of the atmosphere, is what the camera receives from space, the reflection, but it has these effects of the atmosphere in every pixel. The image looks bluish, so it's not right. Level 2 is surface reflectance, and that is the highest level of reflectance and thermal data we need to use. Always choose surface reflectance data. All right? Very good. So we will go with level 2. Now, the most recent satellites are 8 and 9. They're currently in space. All the other satellites are already dead. So from those satellites, we get historical data. But if I want to get Landsat data for last week, for 2 weeks ago, past month, I need to select Landsat 8 and 9. And then click on results. Oh, I have few gifts now. I don't know if I have enough for the rest. Oh.
Then
Who will win?
after I select Landsat 2 results.
After you select Landsat 2 results, yes. Now you have on the left, on this side of the monitor, you have a tiny pictures of the Landsat, right? Okay, those are the images for my area of study. How can I see what area the Landsat image cover? I click on the foot icon. That's the footprint. So I see that it goes all the way to the ocean, goes down to the El Fayum. So I pretty much, with one Landsat image, I can evaluate the entire New Delta. I don't need another image. I just need this image to evaluate the entire Delta, the entire New Delta area. Good. But is this image a good image? For a price, who can tell me what's a good image?
We found cloud or not?
You already win.
No cloud.
Okay. No clouds. All right. Oh. Okay. Short on this. Okay. Who else answered? You answered too? Okay.
I am the first one.
All right. I'll give you extra.
Okay.
All right. So how do I check which image has no clouds? Well, I
The
need
second
to
picture.
click
Yes.
on the picture. And what do you think?
That's a cloud.
Yeah, cloud. All right. Now, okay. What about the next one?
That's a cloud also, it's right, but for the area of study, it's okay.
For the area of, do you say do you agree? For the area of study, it's okay. All right, that's good. That's true because we can clip the area. Okay. All right. We'll give you a prize. All right. All right. Yeah, I'll give you a prize. Yes. Yes.
I would like to show you something. Yeah, that's like a dream. Why it's look like this?
Oh, you have to deactivate the footprints and the pictures every time you check a new place.
Alphonse sees it.
Okay. Now let's keep looking for an image. This one, what do you think? Has clouds? Yeah. What do you think about this one? Yes, this is perfect. So to download the data, you have to have an account, and you already know how to create an account, right? And you have to be logged in. Once you are logged in,
Yes.
you can click on the green arrow here, right? You click on that green arrow and you get this window. You can then click on product options and you get this other window. What I want to download is everything. And I click here. Save as. You decide where you want to save it.
Alfonso, it doesn't activate it.
Did you log in?
Yes.
Okay. Oh, probably I have for 3 more people, I think. Who will get a prize? Okay, it's downloading the data, it's downloading everything. So remember that
Download everything.
it's downloading everything.
I already.
Okay, what are you downloading?
This one.
No, that's not for download.
Hmm.
Is that green? This one?
This one.
Yeah.
But I would like to see if there is a cloud of.
Oh, deactivate the footprints, all the footprints.
Wait.
That one? Yeah, that one too. Yeah.
Yes.
That's this image. Deactivate. Change. Yeah.
So
Yes.
to
And
download,
yeah.
I do like this. And then download everything.
There. Okay. All right. My Landsat image has been downloaded. Hooray. Now I can do analysis. Okay. Now pay attention. It's
Add
time.
all, add
It's-
all to bulk. Click in the first.
Yes.
Add.
Okay. So now that I have the data downloaded and save it on a place that I want, now I need to go where I save it. So the file that is downloaded has this long name .tar where I download the file. Where you in the folder you downloaded is there. Okay. So
Here.
you already have the data unzipped. So here I just need to use WinRAR and extract the files, and I will get this folder. And this is all the bands that Landsat offers me. Okay, for a price. And those who won don't answer. You already got a prize. So for those who haven't answered, Landsat has band 1, 2, 3, 4, 5, 6, 7, and 10. Who can tell me what is band 6? What is the name of the spectral region that band 6 of Landsat is monitoring? 6. Band 6.
I click it.
But they're gonna take some
6.
time.
Wait.
For a price.
Which color is it? Green.
Okay.
There is a name.
Landsat 8 bands.
60, the short wheel.
Okay, let's see what NASA has to tell us.
Yeah, 6 is the short
What is 6? What's the wavelength of band 6?
wheel.
Okay, what the table says. From which region to which region is shortwave infrared?
1,100 to 2,500.
Yes. If this is band 6 is shortwave, what about band 7?
Band 7 is
No, 7 is band 10.
7 short waves.
This shortwave. What about band 1?
band 1 is blue.
Blue.
No.
Okay, what about band 3?
Band 2 is blue.
Band 3 is green.
Band 3 green.
Okay, who said green?
Yes, band 3 green.
Okay, who didn't won? Who didn't win a prize? Okay, who did not win? Who didn't win? Okay, who else answered green? Okay.
I answered after them.
Okay, I'm going to give you prize. 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 Yes. Sergio, you don't get prize. Did you win? Okay.
ده ما انت ما نزلتش البرنامج.
All right. Let's remember.
I want to
You should search for a wheel.
Okay, now it's not this one.
Yeah.
Okay, here is the table. Okay,
This is the first.
remember, I deal with a lot of children. Okay, so I know how to get your attention. Okay, look at the screen. What are you see? What did you see? What do you see? Sorry. This is how we read. So I gave you a table to memorize, right? I told you if you memorize this table, you can do remote sensing. If you don't memorize it, you don't get a certificate. So here is how the bands of Landsat matches the wavelength that we are given. Remember, LASA, no company is going to tell you, oh, this is blue, this is, no, they're going to give you this. And if you memorize the table, you know which color or which name we give to that band. That's why it's important to memorize that table. Okay? All right. Everybody with me till now? Okay, so let's assume all of you has unzipped your data. You have your folder, and your folder looks like this, like mine. Okay? Very good. Time to use QGIS. So open QGIS. Okay. Okay. Who didn't get a prize so far? Everybody got a prize?
Yeah.
Oh, okay. Good. Not that prize for me. Okay. All right. QGIS. Does everybody has QGIS? Yes. You got your folder with your bands? Okay. Now, I'll go to layers, and now you can do it with me. Go to layers. Okay.
What is this sound?
Layer.
Click layer,
And just
add layer, add raster layer. Okay. Click there, and you get this window. Click on the three dots. Go to your folder. And now select, I want you to select band 1, 2, 3, 4, 5, 6, 7, and 10.
1, 2, 3, 4, 5, 6, 7, 8. 7, 8.
الرقم تحت.
1 2 3
It's money.
Okay. Open it. You will get this window. Click add.
7 ل 10
1 2 3 4 5
6 و7
Once you see an image behind, you can close the window. Close. Okay, what is the first band you have in this list, in this section? 10, everybody got 10? Okay, what is band 10? Thermal data, right?
You can drop it.
This is band 10. This is the first on my list here. So what you're looking at is the temperature of the surface. Let's go to the new delta, and let's look at the center pivots. I know it's not in colors, but I need to ask you a question. Listen to the question. The center pivots that are on my screen, do they have the same temperature? Okay, question. This is band 10. Band 10 is thermal. That means surface temperature. If I'm looking at the center pivots in the new delta right now on my screen, I'm asking if all the center pivots have the same temperature. No? Are you sure? 100%. Okay, that's true. That is true. The darker the color, the colder it is. And remember, did I tell you that there is a relationship between temperature and ET? What is that? What is the relationship? Inverse. The colder the center pivot, how is the ET high or low? If the center pivot is cold, because I'm looking at the thermal map, is the ET, the evapotranspiration, high or low? Remember the relationship we say. How is it? How is it? Okay. Temperature and ET. What's the relationship? Inverse. The lower the temperature, higher the ET. So you already know this high ET, low ET, low ET, low ET, high ET, low ET. You already can say that because temperature and ET are linearly related. So I already know that some center pivots here has low ET and others have high ET. But after tomorrow, we will learn how to take this data and calculate real numbers. Right now, I'm using my inverse relationship to say these center pivots here has higher ET than these center pivots here. Right. Everybody there?
Yes.
Okay, very good. Now I can uncheck the first band. And now I'm looking at which band. In my case, it's band 7. Do you have band 7?
Yeah.
Yes?
Yes.
It doesn't matter if it's not in order, but I'm looking now at band 7. What is band 7? Which spectral region is band 7? Shortwave, very good. Why is important shortwave? Do you remember why? Why? Remember when we do this figure? This figure, wavelength here, reflectance here. How is the shape of the spectral signature of a plant? If I'm in the blue region, is high or low?
No.
Low.
Low.
Low, okay. In the green,
High. Low.
in the red,
Low.
in the near infrared.
Very high. Very high.
Okay,
Yes.
all right. What happened after near infrared? How the spectral response behave? Keeps going up or down? Okay, after that,
A little bit
goes
high.
up or down? Up or down?
Up because it's thermal.
Okay, what else? Up or down? Down. And here, up or down?
I think down. I think down.
Okay. Right? Why Landsat measures shortwave? Because this is the blue, this is the green, this is the red, this is the red edge, right? And this is the near infrared. But why NASA, why Landsat and SET measure this? Because this is related with water content in vegetation and soil. Okay. Is this clear?
Yes.
Now let's look at the image, because if the image has to make sense with this, let's go back to the thermal. Okay, where are my center pivots with low ET? These ones?
Yes, the darkest.
The darkest one are with the low ET, high ET. These ones, low ET, okay. Keep an eye on this because I'm saying there is a relationship with water content on band 7. I'm looking at band 10. You're telling me this is low ET. Why low ET happens?
Temperature on.
High temperature.
The darkest, the high, the coolest, the darkest.
It could be why a plant will have low ET. When in the growing cycle, a plant has a low ET.
First stage. First planting stage.
Early stages when you have, so let's see, you are telling me here is low ET, right? Now look at band 7, same location. It's telling me there is a higher reflectance in shortwave. Let's go back. High or low ET? This is thermal.
Low. In the dark area, low.
Is high or low ET? High. Okay. Look at this region on the short wave. Low values. So what is saying, there is also an inverse relationship. If band 7 shows low values, the water content in that location is high. There is an inverse relationship between the short wave bands with water content in vegetation and soil. We go back to the thermal, IET in the thermal, low reflectance values in short wave. And remember, there was an index for crop water stress. Who remembers the index for a price? What's the index for stress using short wave band? Yes. Okay. Normalized different water index, it's equal to short wave. I think it was the other way around. Near infrared minus short wave over near infrared plus short wave. This is an index for water content. Why we use SWIR? Because SWIR has a relationship with water content, but the relationship is inverse. And that's what we're seeing in the image. Is that clear? Yes, we need to move to another band. Yes? No?
So the darkest area,
Dark means low, low reflectance.
low reflectance and cold temperature.
Yes.
Okay.
Yes. Okay. Now let's go to band 5. What is band 5? Very good. Yes, you're learning remote sensing. Very good. Okay. Now, same exercise with the thermal. Same exercise. What type of ET I get here? Low or high? High. Look at the same location on band 5. What is telling me? The white, if it's white, is high. If it's black, is low. What is telling me?
High.
Y is high. Now look at this is low ET, right? This is the thermal. Keep your eyes here. What happened with the near infrared? Is high or low? Low. This is dark. Okay. High near infrared. Low thermal. Low ET. Low near infrared. So there is a relation. In this case, the relationship, if the near infrared is high, the plant is healthier, therefore will transpire more. If the plant is unhealthy, the near infrared is low and it will transpire less.
Again, if there is low ET, means a high infrared.
High infrared.
And if it's high thermal, if,
High thermal
high
means
thermal
low
means
ET.
low infrared,
Low ET.
and high infrared.
Low infrared.
Do you have any people about this relation? People.
This relationship
This relationship.
is mostly with playing with the data.
طب وتدي ايه بقى في الانفراريد؟
But let's keep explaining this. So what's happening is, look, this plant is healthy. How is my near infrared? Is high or low? Okay. So when a plant is sick or has diseases or needs nutrients, the spectral signature it goes down. That's what you're seeing here. The area of the high ED has high near infrared. The area of the low ED has a lower near infrared. So there is a relationship.
So because I have some low ET means low infrared.
Yes.
Low ET, high near infrared.
Low ET, low infrared.
Low ET, low infrared. High ET.
Yeah,
high
is a direct relation. It's not inverse. It's
infrared.
direct. Okay. All right. Let's keep looking. Okay. Now, but this is infrared. Let's look at red. What can you tell me about high ET and low ET? About the red. Here.
High ET,
Red.
low red. High ET is low red.
Yes. High ET, the healthier the plant, lower the red. Why? There is a reason.
Because healthy have
Yes, because this is the chlorophyll band. This one and the blue. So when a plant is healthy, it uses blue and red photons to do photosynthesis. If the plant is sick, it does less photosynthesis. That means this value goes up. Okay, again, the red and the blue light or photons are used by any plant to do photosynthesis. When the plant is healthy, we'll try to use as much light, red and blue, to do photosynthesis. When the plant is suffering stress, lack of water, lack of nutrients, diseases, it does less photosynthesis. So it uses less red and less blue light.
هذا باتت
Now, this is the green band. The relationship is the same. You have lower values here in ET, higher values in the green, in the low ET area. The same is with the blue.
green is low ET. High green or low green?
Low ET
Is high green.
Low ET is high green.
High green.
Yes. And the same with the blue. So that's the correspondence. When a plant is healthy, let me draw this better. It does like this. It uses less light. But in the near infrared, we see a drop. And that's why these changes in the spectral response is what we use to calculate vegetation indexes. But we will use all this data to calculate ET. We need everything.
Yeah.
All right. It's clear how to read maps now. Is it clear how you interpret values in an image?
Yes.
Yes? Okay. Because now we need to do algebra. Okay, algebra. What we need to check here are on which units this image are. Let's extend the scale option for the thermal. It's telling me the maximum value is 52,000. The lower value is 41,000. Are those the units of temperature? So what I need to do?
Need to rescale.
Yes, I need to rescale. NASA saves the data in integers, but temperature could be 30 degrees 0.5, 30 degrees 0.11, right? Where are my decimals here? I don't get decimals. What NASA has done, it has converted that float number into an integer by applying an equation. Now we need to do the other process. Apply the equation to convert from integers to temperature. Okay, where are the coefficients of that equation?
It's not
UV.
First 2 files. The text file.
If I have an equation, I need these two parameters, right? Okay, where are the two parameters for the thermals?
The text file attached to
Yes. So open your folder. Okay. And there is a file called that ends on MTL. Open that file. What did I do with my water?
PU beta.
Here it is. Okay. Now, what I'm looking for in this file I'm looking for this information.
any file with extension MTL.
No, it at the end of the name says mtl.txt.
Okay.
This is what you're looking for. It says the multiplication term and the addition term. I need the multiplication and the addition term. NASA in that file is giving me those values. Okay, now I need to convert my thermal map into temperature values. Go to QGIS, go to raster, go to raster calculator. Raster and raster calculator. You will have a list of all the bands that you have open. We are going to work with band 10. So here at the bottom, we will write our equation. So I need to double click on band 10. It will show up at the bottom. Now I need to multiply by a value. So when you use the mathematical operators, use these ones. Don't try to type it. It will show an error. Use these operators. So multiplication, go to the text file and copy the temperature mult band 10. Copy this value and paste it. Then the addition value, add the plus, copy this value, 149, and paste it. Now you have the equation. Okay, now, is everybody there?
No, wait. We search last about temperature.
Again,
Doctor, yes, 2032. And then it's plus
وده
plus this value.
بدور على التيم. اخد ده كده كله
لا لا عايزين رقم.
ده كده كوبي
ايوه.
والجراح هنا حاطه كده.
لا لا الاول حضرتك تحطي البند.
البند
البند
كده
10.
يعني هاخد من هنا بند ايه؟
عايزين بس نسحب البند يعني حضرتك يعني حرك ده هنا.
Okay.
10 اكبر بس دبل كليك عليه.
Were you able to put the equation? Who put the equation?
بس الاول احنا البند دي
Okay. Ready for the next step? The next step is very easy.
The location of the file.
هو ده
Okay.
ده احنا فيلم.
Again. Okay. Pay attention. Go to raster. Raster calculator. You get the list of all the bands. I need to get temperature values from band 10. I click on band 10, double click it, it will show in the bottom. I use the operator multiplication. Then I go to the text file and I'm going to get the multiplant value. Copy this value, paste it after the plus, no, after the multiplication. Now add a plus operator, go to the text file and copy the value 149. Copy, paste it again. Now you have the equation. Okay, everybody there?
Yes.
Yes. Now, the last step, go to these three
First one,
points.
we put the direct.
Click on the 3 points. It will show you,
Times.
Wait,
The first one time.
will show you here. Now give it a name. Say temperature dot TIF.
I should write .tif or just the values.
TIF. Then close it. You will have now here a location where it's going to save that image.
Okay. We press okay.
And yes, temperature.tif. Never forget to put the extension. It's a good practice.
Before we write the file, the output layer, we click the okay.
After you put this, you click OK. Click OK.
على الديسكتوب كده.
الفايل اللي حضرتك سايبه باسم ايه؟
لا ده بتاعنا شغلنا.
تمام. ممكن حضرتك سايبه هنا اكتب
وبعدين اوكي.
ايوه.
Let it.
Make the name. I press OK.
Yes, press OK.
.tif.
Yes,
It will show a new layer.
ثواني بقى.
Okay. Do you got the new layer that says temperature in your QGIS? Very
Yes.
good. Check the range now. The range of values.
150 till 334.
It has to be, the temperature is in Kelvin. So it has to be around 350.
Yes.
Okay. Yes.
But
Okay.
it's still gray. In gray.
Yes. It's still in gray color. Yeah. Okay. Who got the temperature map check in there. Got it? Got it? Okay, here, temperature maps. Yes. Over there. Yes. Okay. Now I'm going to show you how to give it colors. Okay. Colors. Grayscale is good. Scientists in remote sensing are able to read gray colors because we're looking for patterns, light, dark, right? Okay, but not everybody reads on that. We need colors. So click on the temperature layer. It should be blue. Then do a right click and then go to properties. Okay, who got this window? Yes, I need confirmation. Yes. Yeah.
No. Yes.
Okay. Now look at this option. It says color gradient. Open that window. Yes. No, here, go to the first one. Render type. The render type, we want to select single band pseudo color. Look, this is what happened when I selected. Did you got something similar?
Which one you select? Single band?
Single band pseudo color. Okay, now, do you like these colors for your temperature map or you want other colors? Yeah.
ما هي دي البروتستان وده
This is another version of QGIS. Okay. Who got the same window as me? Confirmation, need confirmation. Okay. You like these colors? Okay. Yeah, but you next to these colors, you can check other colors. Okay, so you can choose magma. Okay, and this type of colors are more related with temperature. So now,
but we need to invert the color scale to be the darker ones with the higher temperature and the light.
There is an option here that says invert colors. Yeah. If you like, what is saying this, I'm going to keep dark colors to the low temperature values and bright colors to the high temperature values. But if I don't like that, I could invert it.
Yeah.
And there is an option here at the bottom that says invert colors. If you click there, now, did it? Okay, now click apply and click OK. Let me see. Something is, oh, did you get the other color? Because mine is doing the first one. Let me redo it again. Color ramp. Magma. Okay. Who got a map like this? Yes. Zooming into the new delta, look at the center pivots.
ولا طلع
لا طب
ولا
ممتاز.
خضر.
زي الفل.
Okay, now that I have my map like this, let's check what's the temperature of the center pivot. How do I do that? How can I know the temperature of this center pivot? There is a tiny icon here, follow my mouse, that says I, identify features. Click on that icon, and now click on any part of the image. So now you can get on this side of the screen, the temperature in kelvins of that center pivot.
ليش الاي دي اصلا؟
موجودة فوق خالص.
فين؟
You can click on the dry area and compare the temperature with the center pivot. Who can tell me what's the difference in degrees? What's the value?
306.
No, what's the value of the difference of the dry area and one?
About 10 degrees.
We can do, look, here is 317, here is 305, about 10 to 12 degrees. So this is how we get our maps. This is band, this is the temperature band.
أنا عندي كلاود.
Kelvins. This temperature map is in Kelvins, no Celsius, no Fahrenheit, Kelvins. Okay. Okay. What in my image, what's the temperature of the ocean? What's the temperature of the ocean?
I think 20.
I got 291.
86.
So is the ocean colder than the crop?
Yeah.
Yes, open water is always colder than vegetation. The little lake that we have at the bottom of the image, what's the temperature? 298. There you 91, yes, depending on the location, it will change. But now you are seeing the temperature of these two rivers here. So temperature and sediments, water temperature and sediments in the water are correlated. So if you are studying, let's say, natural or river corridors, that temperature will be important. Also, if we have fish in that river, on that stream, temperature is important for fish. There is only a range of temperature values that the fish can live. If the temperature of the water goes higher than, fish will die. It cannot get oxygen because of the high temperature of the water. So Landsat is not only used for agriculture, it's for environmental purposes, for studying coastal line, to study lakes, to study bad areas. So we did this part. Okay, questions so far? Because we need to move to the next step. Is this clear so far? Okay, everybody is able to follow up. Very good. Now, the exercise that we need to do is to every band, we need to do the same exercise. So band 7, 6, 5, 4, 3. So this is the exercise that we do when we use QGIS, but when we do coding, we just copy and paste, copy and paste, copy and paste. So there is some benefits on doing it by code. But we're going to focus only on two bands. We're going to focus, and we need to do this transformation for the near infrared and for the red. We need to transform the digital images into reflectance values from 0 to 1. How do we do that?
Band 4 and 5. Band 4 and 5.
Very good. Band 4 and band 5. How do I do that? The same. But different coefficients. Different coefficients for my equation. So where are those coefficients? Are here. Reflectant multiplication, reflectant addition. These are the values are the same, but I need to do band 5 and band 4. So let's do that. Go to raster calculator again. Now I'm going to do near infrared first, so it's band 5, double click, multiply by this value, 2.7 to the power of -5. And I'm going to add, in this case, is a minus 0.2. So instead of saying plus, I'm going to say minus, and I'm going to type minus 0.2. If I'm doing band 5, it's near infrared, so I'll go to the 3 dots on the top, and I'm going to call it near infrared .dif. Save. Okay. Fun? Yes. This is how I entertain myself over the weekends. Yes. You're done? Or should give you a prize for that.
You're done? ايوه بس ده هنا الريفرنس يعني مش لازم تمبريتشر
لا انت دلوقتي 5 6 7
Oh, wait a minute. Right for one. No. Has to do the 2 bands. Band 5 and band 4. Not only one. Okay. Now I'm going to do band 4.
band 4 و5 فرق ايه من فوق محمد
رسل
محمد تاني.
All right. Okay.
لا تاني الكالكوليشن.
Both. All right. Very good. Yes.
I also both.
You're also done with both? No, you have to call it what's its name?
احنا كنا
Four.
كنا واحد ازاي
What is band 4?
اتضح البند الانفراريد ده قوي.
There you go. That's what you call it. Okay. Right. Who else finished the 2 bands?
اشمعنى بند 10 خدنا التمبريتشر؟
هو بند 10 عشان بتاع التمبريتشر.
All right. Done. Okay. Now your job is to give the colors to the 2 bands.
Tú calculated.
If you already calculated, now give it colors. How you give colors to the bands?
وعند الاكستنشن اوف ذا فايل TIF.
TIF. Always TIF.
اوكي. ابلاي. ومفيش
Yes.
And 5.
نحسب الباقي.
Color.
هتاخد بالك.
White and black. Color white and black just.
لا ما عملناش
Color.
الكلام زي ما انت عايز تختاري وقت. بس بص طلع زي كده.
ما عنديش. Where is the color?
Done. Very good. All right. Apply colors.
Yes.
Both bands.
Yes.
Okay. Look. What is the name of the band that you have on top? I have red. Red. Or you have infrared, it's okay. But do this exercise. Zoom in into the center pivots, any location, and do this. Check in, check out that top band. Check in and check out. Check.
Reverse.
Just to see the.
It's just,
The red one gives more brightness.
yes. Okay, very good. Now let's check the values of the red and the near infrared in reflectance. Here, how do we do that? How do we get the values of the pixel for red, for infrared? I go to the eye, and then I click on the image. Okay, for near infrared, I got 0.38. Okay, let me do it again.
Podemos tener también una tabla con todas las capas con su valor respectivo.
Sí, pero solo quiero esas dos.
Ay, pero igual solo se puede hacer con las activas.
Ah, ya. Tengo que seleccionarla, ¿no?
Sí, solo como lo estaba haciendo. Ahora aquí abajo donde dice View Tree,
Ajá.
en vez de View Tree, tabla. Exacto. ¿Y qué quiere? ¿Current Layer o quiere las activas? Hace clic en este, sino ahí clic. Dice.
Current layer. That's
Yeah,
good. Yeah, that's okay.
No,
That's 3 is okay. Okay.
Okay.
So if you click on a center pivot, but you need to read the value of the band, you first have to select it here. Has to be in blue. And then you click on the band. Now it's telling me that the red band is 0.11. Now I select the near infrared, go to the same location, and it's telling me the near infrared is 0.4. Does it make sense with my spectral signature? Is the red value lower than the near infrared?
Yes.
Yes.
Check again. Is your red value for the same location lower than the near infrared? Yes? Yes. Because if it's not, the orders are, when you did the raster calculator, you put the opposite order. Always in vegetation, the near infrared is higher than the red. All right, you guys are learning remote sensing.
To read something.
All right, now we need vegetation indexes. But now that I have the red and the near infrared, I can start doing it. Okay, how do I do or how do I implement NDVI?
Near infrared plus minus red divided by near infrared plus minus.
Okay, what's the equation again?
Near infrared minus red divided
All right. Okay. I need to do now this in raster calculator. Okay, how do I write this in raster calculator?
Between brackets.
Yes. Be careful. You need to put parentheses here. Okay, like this.
You want to put down. That's first. You have to see which layer you are.
With parentheses.
You want to go to
Don't do it without parentheses. You will get weird numbers. Okay. We are expecting your values to be from 0 to 1. Okay, who can do it? You're done? Well, you're fast. Hey, my last prize. Oh, but I haven't seen your map, so I need to check. You're done?
Yeah.
All right. NDVI? NDVI.
But,
All
but,
right.
but there is from minus
Tiny value.
0.49.
I can explain.
Give us it.
The range is one.
The mathematics.
Minus to positive, but not from 0 to 1.
Yes. Let me calculate and I can explain.
Okay.
All right. Raster calculator, parentheses, near infrared, minus red, close parentheses, divide, open parentheses, near infrared, plus red, close parentheses, give it a name, ndvi.tif, save. Okay.
لازم نعمله هو مين ال ده بند كام؟ ده بند 5 والريد بند كام؟
Too easy.
والريد بند 4
There you go. Very good. I'm out of gift now. I'm out. But good. Give it color. Give it color. Very good. Okay. That
لا اللي تحت منه بند
let's see.
يبقى انا خدت رقم تاني عشان كده لازم اعمل 4 تاني
5
This is awful. These are not the right values. Let me check my equation.
I checked more than once and get the same data.
Remove layer. Go back to raster calculator. Okay.
ايه الفرق؟
يعني
سميها بقى بند
That's value from minus 1 to 1.
Yes.
Not 0.
Because the negative values are close to 0. Are close to 0.
Yeah.
And we force it to be 0.
Yeah.
Yeah.
Okay.
Okay. Okay.
Plus.
Yes.
أربعة بقى ده اللي بند 4
Plus red.
remove layer
Close it.
كمل 4 تاني
عملتها ازاي؟ خلي بالك نفس المشكله.
يعني عملتها ازاي؟
صلحها برضه
Hey, Sergio. Yes. Okay.
Okay, where's Sam?
ده اسمه ايه بقى؟ الريت.
So that was.
¿Por qué me está saliendo valores enteros?
Minus el rate.
Y esto es lo que hizo para.
Espera, espera. Esta red
Sí.
is the 6 0.
Yeah.
Near infrared 0 point a esto. Voy a eliminar este de acá.
Ya. El NDVI le ha salido ese valor.
Valores enteros. Raster calculator, acá están mis dos bandas.
Sí.
Not greater than.
No
Minus.
podría salir ese valor. Ya.
Como que me está forzando un valor entero. No sé si tengo que
Sí.
ponerle, cuando divido, le pongo un punto.
No. Probemos de nuevo a ver y vamos a ver en las opciones del layer. Debe haber una opción que se vean los valores. Qué raro que le esté pasando.
Ahí
Ya.
está, mira.
Está bien.
Minus.
Plus.
Vamos acá. Voy a
Ya.
darle un nombre 2 en DBI 2. ¿Okay?
Se lo han rodeado como enteros y nada de floatings, ¿no?
Sí. Entonces, clic OK.
So.
Esperemos que tal vez sea.
وغالبا في حاجه في الرصد عن حضرتك في الويب سايت جنبها عن لا برضه
Valores muy altos.
Sure.
I have the same problem.
Yeah, let me query this. Oh, look at the values. The values are okay.
The display son.
What happened is there are some pixels that are negative, reflectance negative, and that's it's not outliers. What is happening is that look at your range of values of the red and the near infrared. Do you get negative values? Can negative reflectance exist?
No, but it means
When can negative reflect can exist?
the water bottle.
No.
For cloud.
Either is zero, no reflections, or a value higher than zero. But negative will be absorption, but more than the light is falling in.
Black hole. Like a black hole.
So why happens these values? Remember this conversion we were doing? Those conversions are an approximation. And because it's a mathematical conversion, some pixels might have a very low reflectance. And when you apply the equation, you get these negative reflectant pixels.
You can adjust it by adjusted the maximum and minimum value.
Yes.
Es como un if.
Yeah. So
It's the same.
still, let's go. You calculated your NDVI. Despite the maximum values, go to properties.
So I have to go for witness.
Yes.
And in contrast enhancement, what did you choose?
I choose the first, I change
Range
single
from
band degree
Yes.
to the next.
To the color.
Yes, this one.
Yes.
And change it from 0 to 1.
Yeah.
Minimum value.
Here.
And
In
the-
0,
Yes. And the maximum value is 1.
1.
And choose your color.
Green is okay.
Okay.
Apply
Okay. It's
and
working.
okay. Yes. Very good. Thank you. There we go. We got NDVI now. Okay. Now, remember the exercise we did with the one soil app. Can you tell me based on the NDVI if the fields are homogeneous or not? So we got the NDVI. Okay, zoom into the center pivot, zoom in. Are the center pivots uniform in NDVI?
No.
Why?
Different colors.
Yes, but I am asking you as agricultural irrigation engineers, why NDVI, a measurement of vegetation health, is not uniform in the center pivot? What could be happening?
Maybe issue.
Issues, right? It could be many things. Okay. What? Let's make a list. What are the factors that can affect the values of NDVI?
Harvest.
Well, if harvest agricultural, cultural practices. Okay. What else? Water is any type of stress, water, nutrient, or insect pressure. What else?
Temperature.
Planting dates. Okay.
Soil type.
Soil. Soil is going to be one of the strongest factor affecting the vegetation growth. So, but in an image, in one center view, we can have all the factors together or few factors. NDVI doesn't tell you what is the factor. It only tells you if it's healthy or not. And give us a sense of uniformity of the growing of the vegetation. Okay. So with this, we can navigate. And now, if we see low NDVI, that means if there is low vegetation in that location. Now, let's uncheck the near infrared. Let's uncheck the infrared. And let's do that check-in, check-out with between the NDVI and the temperature. What relationship do you find between NDVI and temperature?
Picture is high at the NDVI high values.
Okay, look at your values.
Low temperature, high value.
The proportion relationship between the temperature.
Reverse.
Inverse relationship. But in this case, okay, what is the relationship between NDVI and temperature? And this is the very fundamental concept to do ET. NDVI and temperature. What is the relationship? Like this, like this. Inverse relationship. Okay, but there is a caveat. It's not linear.
You see the value.
It's a triangle.
When 174. If I do this,
If we could choose another layer. Just need to
If I select the pixels of a center pivot, okay, and plot all the NDVI values of the center pivot and all the temperature values of the center pivot, I got the inverse relationship. You are right on it, but instead of having a line, I get a triangle. So this is called the triangle method. This is the very first technique to calculate evapotranspiration using temperature and NDVI. All the other models derive from this. This is the key concept between vegetation and temperature. So how we read this value? What was low temperature? What does it mean for ET? High ET. High NDVI, what does it mean for ET?
Low.
High NDVI.
High ET.
Ask ET here. Hot temperature, what does it mean for ET?
Low. Low.
Low NDVI, what does it mean?
Low ET.
Okay, in terms of vegetation, what does it mean?
Minimum 80.
Vegetation.
Low precipitation.
Low vegetation,
High temperature.
high temperature is kind of bare soil. What's the evapotranspiration of bare soil? High or low? Low ET. So basically, what in the past, I'm talking about like 20 years ago, this was the methodology used to calculate ET. You take, let's say, this center pivot area, plot the NDVI pixels, plot the temperature pixels, get the values, the high NDVI values and the high temperature values, get the low NDVI, the high temperature, and from here we interpolate. We are going to say here that the ET fraction is very close to 1. The ET fraction is very close to 0. So we'll say 0.8, 0.6, 0.4, 0.2. And we interpolate. So it was a sort of an indirect approach to calculate ET. It's still used, but nowadays we have taken this concept and rearranged it into a energy balance relationship. But this relationship, if you have high NDVI, low temperature, you should expect very high values of ET. The other direction is true. Low NDVI, high temperatures, low ET. So vegetation and surface temperature are related to ET. Fun? Okay. Questions? Okay, so we are 5:30. Okay.
That's enough.
Is enough?
Yes.
Yes, everybody agrees? No more work? Time to go to sleep? Okay. All right, we will stop here now. Questions? Okay, so now you are familiar with QGIS, with plotting, with giving color maps. Now when we go to tomorrow we go to the field and collect the data. The day after tomorrow, you will be given images and we will be displaying it. We will be putting color maps. We will be putting through code. So it's a similar exercise using the QGIS. All right. Okay, let's stop here.